Okay. So what the question is that there is a car uh, which is going on the road, and this is a circular track. Okay, and they put also this uh, direction, directions. This is north, south, east, and west. Okay, and north always shows. You can take this. North always shows the positive y direction, and east always shows the positive x direction. West is negative x direction, and south is negative uh, y direction. If you put your coordinate system like this is y and this is x. So what it tells that, the car is going from this point to this point on the road, but this section of the road is a perfect circle, what the problem says. And by going from this top position, okay, with this coordinate system, it's just on the y-axis. Uh, okay, this direction shows north. And right at this point, the car is going toward east. Okay, but of course, as it moves on, it turns downward because the track is circular. Okay, so it moves a distance, a path distance d, and it comes over here. As I said, this is the arc of a circle. Okay, we can, let me switch the better screen over here. Okay, so, okay, let me also erase this and put it over here. This is y and this is x. So this section is the arc of a circle. For this, you can just draw from the initial position of the car over here, draw a straight line like this. Okay. And this is the final position of the car after it goes a distance d. All right. And again, from here, you can draw a perpendicular line perpendicular to the direction of the motion at this point. And let me draw this. And you will see that these two lines will intersect at this point. And you can just, easily say to me that this point is going to the center of the circle. The center of the circle that the car is, trying to complete. If the car goes in the same fashion as always, uh, going on this circular track, it will come to the initial position after some while anyway. So what is the question? The question is, the car is traveling a distance. Let me check what is the amount of distance given in the problem. This d distance d is 840 meters, and the angle is 35 degrees. Okay. Again, let me check and switch on this next. Okay. So the problem says this distance d, the path. Why did it? Or okay. Yeah. Why? Okay. This d distance that the car goes is 840 meters, and the angle that the direction of the car at this point, at the final position at this point, the angle it makes, the angle of its direction of motion, this red arrow shows the direction of the motion of the car at this point, okay? After it travels a distance d from this initial position over here, at this point, the car is somewhat traveling in this direction. It is neither in the east nor south, but somewhere in between. And this angle the problem gives is 35 degrees, okay? So with this information given, the distance it travels and the angle of its direction and rotation, uh, the question is, what is the radius of this circular track? I mean, since the car is traveling on a circle, if it's going on a circle, this circle must have a radius, and the radius is this one, okay? Similarly, on this line, the length of this line is going to be, again, r, because it's a circle. So this is the question, what is r? For this, uh, you use your geometry knowledge, and you can solve this question by using geometry. It's not much physics on over here. By geometry, you know that this d has an expression in terms of r and theta. Okay, and I can simply write this relation as r times theta. And I don't know if it's clear for you. This is coming from geometry. The arc length of a circle is just equal to whatever the circle's radius multiplied by this angle. But I just put this angle to be uh, the angle between this line and this line, because this line and this line just locates the position of the car in the initial point and the final point. And d is the arc length it travels. But I just put this theta to be equal to this angle. And the only thing that you should check this one, okay? Let me first put this angle to be different. Let's put this to be phi. Let's put this to be phi. And I will prove you that this angle is nothing but is going to be just equal to this angle, theta, which is nothing but given in the problem to be 35 degrees. And the other thing is that if you have this relation, and you can check your geometry books anywhere or internet, this is there, and you can verify this. In this equation, the angle is always given in units of radian, not degrees. You should be careful about this. The angle should be taken in this equation in terms of radians, not degrees. Okay, so that means you have to, if you are given the angle in terms of degrees, you have to convert this to radian and multiply it by r, the radius, to have this distance of the arc. All right, so how come this you can get this phi is equal to theta? Uh, for this, what you do is just, I will, let's, bring this line so that I want to bring this dashed line and this one crossing at this point, because I want to draw a vertical line downward, and this vertical line I'm putting is just parallel to this line, okay? And this line that I show, this line of this red direction had, this red vector. This red vector is just showing the direction of the car at this point, okay? And this line, sorry, this line and this red is always at 90 degrees. I hope it is clear for you, because at any point, if you draw this radius line to a point, any point on this circle, if you also draw a tangent line at this point, this line and the tangent always makes 90 degrees. Okay, this is also another fact from geometry. So this angle is 90 degrees, and this dashed line and this one also is at 90 degrees. Okay. So if this angle is theta, this angle is going to be 90 minus theta, right? But if this angle is 90 minus theta and this angle is 90 degrees, this angle should be theta. Okay. If this is theta, this angle and this angle are inverse angles. They must be equal to each other because this line is just crossing these two parallel lines. And this is again from geometry. So that makes phi equal to theta. Okay. And from this information, d is equal to r times theta. But as I said, theta is going to be converted from degree to radian. So how do you convert this? Let me first, uh, rearrange this equation so that we can solve for r. R is going to be just theta divided by, sorry, d divided by theta. D divided by theta. Okay. And d is already given because you want to find the r in terms of meters. D multiplied by 1 over theta. Uh, 1 over theta, let me put these numbers. D is 840 meters. And theta is 35 degrees, but you have to convert, as I said, this to radian. 35 degrees, let me do this conversion over here. Theta is equal to 35 degrees divided by 360 degrees, and this multiplied by 2 pi. Why? Because if 2 pi radian is 360 degrees, and what is 35 degrees in terms of radian? This is the conversion equation, okay? So I put over here 360 degrees and 1 over 2 pi.